Good morning, everyone. Today I'll be discussing regarding the problem of decimation in time algorithm. But before that, I'm sharing the screen so that all of you can see. Okay. So in the last class, we have started the decimation in time algorithm. I've explained you the butterfly diagram. What is it? How is it calculated? How is it done? Basically, you see the butterfly diagram. Again, let me repeat. You see this butterfly diagram. It's a very simple form of butterfly, and the input x0 and x1, and the output is y0 and y1. So y0 is equal to x0 plus x1, and y1 is equal to x0 minus x1. Why minus x1? Because the line between x1 and y1 contains the -1 factor. Clear? This is the way of drawing a butterfly and expressing it in equation form. Now always remember that a butterfly, there are many stages in butterfly. Like day before yesterday, I told regarding the stage. So how many stages in case of a problem, if you are asked to draw a butterfly diagram, then how many stages? The number of stages involved in a butterfly diagram is this: log 2 base n, log n to the base 2. So if n is the number of samples, if n equal to 8, then there will be 3 stages. If n equal to 4, then there will be 2 stages. Okay. If n equal to 2, there will be only one butterfly, one stage. Like this. This is a one stage butterfly. This one. This simplest form of butterfly is a one stage butterfly. Okay, this one. This one is a one stage butterfly. Okay. So today we will, perform a problem. You see, this is a 8-point DFT 0 to 7. So how many stages we are having? Stage 1, stage 2, stage 3. Clear? And one more thing, let me remind from the day before yesterday's class regarding the diagram of butterfly. You see, you have to add or you have to multiply the Tweedle factor always with the input which has a backward direction data. Okay, so this x4 you see, this is backward direction. x5 having a backward path. x6 having a backward path. Again, x7 you see having a backward path. So in all the backward paths, input of the backward path is multiplied by a Tweedle factor. Clear? In stage 1, it is W8 to the power 0. Why W8? Because it is an 8-point DFT. So this is an 8-point DFT. So W8. Again, for stage 2, it will be the two backward paths. You see, this and this for x1 and x5. So W80, W82. Here also W80, W82 for x3 and x7. Again, in the third stage, the backward path will be for these four: x2, x6, x3, x7. Why? Because these four are having backward paths. And the Tweedle factor, serially it will be W80, W81, W82, W83. Clear? Oh. Very easy basically. Now let us see a problem. It will be very clear to you using this problem. You see. So you're asked to find out the 4-point DFT of the sequence xn equal to 1, 2, 2, 1 using DIT-FFT algorithm. What is this DIT-FFT? DIT-FFT means decimation in time fast Fourier transform. Okay, in short, I've written DIT-FFT. Likewise, when I'll be writing the decimation in frequency, then I'll be in short writing DIF-FFT. Decimation in frequency, fast Fourier transform. Clear? Okay, one more thing, let me remind you. For these butterfly diagrams, always remember the DIT means the decimation in time has the inputs in bit reversal order. You see 0, 4, 1, 5, 2, 6, 3, 7. But the outputs are in serial natural order 0, 1, 2, 3, 4, 5, 6, 7. You can notice from the diagram itself. That's why I told then before yesterday that I'll be explaining bit reversal in the next class. Today I'll be explaining bit reversal. First, before learning bit reversal, you should know the problem related to DIT. Then it will be more clear to you. After that, I'll be teaching you bit reversal order. What is it and how is it done? It's very easy basically. It is all related to your binary systems. I think you have studied in digital electronics, binary code, how to decimal to binary, binary to decimal. It's all related to that, nothing else. Okay. One thing just remember, before learning bit reversal, think that the input is in a shuffled manner. Okay, I have shuffled the input. So input is in a shuffled manner, output is in natural manner. Okay. Before learning bit reversal, not after that. After learning bit reversal, obviously you will be saying that the input is in a bit reversal manner and the output is in a natural manner. Clear? So now come to the problem. You see, x1 equal to xn equal to 1, 2, 2, 1. So it's a 4-point DFT and equal to 4. It's written here. Now, how many stages will this 4-point DFT have for butterfly diagram? Log 4 to the base 2. You see, I've written number of stages equal to log 4 to the base 2. It's given 2. That means there will be a 2-stage butterfly diagram for this DIT FFT algorithm for this sequence xn. Okay, now see at the butterfly diagram. How is it? You see, I've just written the value of xn. Follow the markings that I'm doing here. I've just written the value of xn at the input side. Clear? 1, 2, 2, 1. Xn equal to 1, 2, 2, 1. Input 1. Input data. So I've written the input data initially. Okay. Oh. Now, see, I have marked capital A, capital B, capital C, capital D. These 4 points. And individual 2 butterflies I have drawn. One with AB, one with involving CD. Okay, with AB, I have drawn the butterfly as it is drawn, as the normal butterfly is drawn. With CD also I have drawn as the normal butterfly is drawn. And since B is having a backward path and here D is having a backward path, so these 2 backward paths need to be multiplied with the Tweedle factor. So at stage 1, since it's a 4-point DFT, so W4, here also W4, and initially 0, W4 to the power 0, W4 to the power 0. Clear? So this is O11, O12, O13, and O14. Okay, these, just wait a minute. This O11, O12, O13, and O14. These are the outputs of stage 1. Remember, outputs of stage 1. Clear? So I have marked them as O11, O12, O13, O1. Okay. Now with O13 and O14, I have given the Tweedle factor W40, W41. Why? Because these 2 paths, O13 and O14, are having backward paths. You see, this and this. And the input of stage 2, I have marked them as A1, B1, C1, D1. Clear? Okay, I have denoted like just A1, B1, C1, D1 for your convenience, nothing else. It's not mandatory. If you don't want, you cannot denote also. Okay, but this Tweedle factor, these arrows are mandatory. This is the arrow. This you have to give. This is a continuation. It is showing that 2 2-point DFTs combine to make a 4-point DFT. Is it clear? This one is a 2-point DFT. This one is a 2-point DFT. So these 2 2-point DFTs combine to make a 4-point DFT. You see? Okay. Now, since C1 and D1 are having backward paths, so the arrows will be upwards. A1 and B1 are having forward paths, back arrow will be downwards, and this are the usual arrows. Now C1 and D1, since they're having backward paths, so they will be marked with -1. Here also you see B is having path -1, D is also having -1 because they are having backward paths. So they will be multiplied with -1. So here also C1 and D1, since they are having backward paths, so their path will be multiplied with -1, not the backward path, the path which is horizontal. That will be multiplied with -1. And as usual, our output is in a natural order, in the normal order, 0, 1, 2, 3. Then you will ask, sir, the input is also in the normal order? No, input is not in the normal order. Okay, input is not in the normal order. It may seem to you that input is in the normal order, 1, 2, 2, 1. But you see, 1, it's 1 here. Then the second 2, this second 2 means this 2. This 2 is this one. Okay. Then this 2 is this one. And again, this one is this one. Clear? So the input is in the shuffled order. The sequence actually it is 1, 2, 2, 1. So you might not understand that whether it is in the shuffled order or not, but it is in the shuffled order. Okay, it is in the shuffled order. Don't make mistake. Suppose it is 1, 2, 3, 4. So you will be writing 1, 3, 2, 4. Not like this. There is a meaning behind it. The meaning is known as bit reversal order that I'll be explaining. So come to the problem now. We have drawn the butterfly diagram for n equal to 4. Now, output of stage 1, you see, O11, O12, O13, O14. Now you tell me, O11 will be what? A plus B into W40. Okay. A plus B into W40. W4 is at the input of B. So A is what? 1 plus B is what? 2 into W40 is 1. We know W40 value is 1. So it is 3. Similarly, O12, what it will be? A minus B into W40. So it will be 1. Minus 1 basically. 1 minus 2 into 1. So it is minus 1. Likewise, O13 and O1. Clear? Okay. Now, this output for stage 1, and it is the output for stage 1, 0, 1, 1, 0, 1 means O11, O12, O13, O14. And this A1, B1, C1, D1 are the input for stage 2. So A1 and B1 will be same as O11 and O12. But C1 will be O13 multiplied by W40 and D1 will be O14 multiplied by W41. You see, input for stage 2. A1 equal to O11, 3. B1 equal to O12, minus 1. C1 equal to O13 to W40. So 3. And D1 equal to O14 into W41. W41's value is minus J. So it's minus J. Okay. So now, what is our input for stage 2? Input for stage 2 is 3 minus 1, 3 minus J. These are the inputs for stage 2. 3, A1 is 3, B1 is minus 1, C1 is 3, B1 is minus J. Okay. Now, what is the output for stage 2? You see, output for stage 2. This is the output for stage 2. X0. X0 is what? Obviously, A1 plus C1. We can go to the butterfly. You see, X0. X0 is what? A1 plus C1. X1, what is it? B1 plus D1. X2, what is it? You see, A1 minus C1 and X3, B1 minus D1. Okay. So, likewise, you see, A1 plus C1, b1 plus d1, a1 minus c1, b1 minus d1. So 6 minus 1 minus j, 0 minus 1 plus j. It's very easy. So this is your required DFT of the sequence 1 2 2 1. This is the DFT. This is your DFT. 6 minus 1 minus j, 0 minus 1 plus j. Clear? Clear, everyone? Okay. Now, I have put up a comparison between the DFT and FFT. Okay. DFT and FFT, I have given a comparison, like if number of points n equal to 4, then in DFT, the complex multiplication in DFT will be n square, we know, as per the formula. But the complex multiplication in FFT, it's much reduced. It is n by 2 log n to the base 2. Okay. So for n equal to 4, in complex multiplication of DFT, you get 16. In complex multiplication of FFT, you get 4. But what is the speed improvement factor? The speed improvement factor is nothing but the complex multiplication of DFT divided by the complex multiplication of FFT. You see, n square divided by n by 2 log n to the base 2. That means here 16 divided by 4, which is 4. Now for n equal to 8, complex multiplication of DFT is 64. Complex multiplication of FFT is 12. 64 by 12, 5.3. For n equal to 16, complex multiplication of DFT is 256. Complex multiplication of FFT is 32. 256 by 32 gives you 8. So if you are asked in exam regarding the speed improvement factor, and if you are given the number of points n, then first you have to find out the complex multiplication in DFT, then you have to find the complex multiplication in FFT, then you have to divide those two, DFT divided by FFT. Okay, you'll get the speed improvement factor. Clear? It can come in short question, it can come in normal question also. Now come to the most important thing that you are waiting for. It's bit reversal. Okay. You see, in decimation in time algorithm, this I have not written basically. It is very short given in book. So I've just taken out the image of the book only. Okay, it's for you. So in decimation in time algorithm, it's found that in order for the output sequence xk to be in natural order in DIT, remember our xk is in natural order, means the output is in natural order. So the input has to be stored in a shuffled order. I told you shuffled. The word shuffled is used here. The input sequence has to be stored in shuffled order. Now for n equal to 8, what should be the input sequence? For n equal to 8, you see, in the previous lecture, I am giving you the example of previous lecture. For n equal to 8, you see. This was the butterfly for n equal to 8. So for n equal to 8, what is the input? 0, 4, 1, 5, 2, 6, 3, 7, right? Come to this place again. You see, we know that the input sequence is, for n equal to 8, the input sequence is 0, 4, 2, 6, 1, 5, and 3, 7. Clear? Okay. This shuffling of the input data sequence has a well-defined order. ये मतलब जो shuffling हम लोग किए हैं, जो किया गया है बुक में, ये ऐसे ही नहीं किया गया. इसका एक order है, इसका एक मतलब अपना एक वजूद है. ऐसा मतलब अपने मन से मनगढ़ंत लिख दिए, not that. Okay. So what is that basis? वो basis क्या है? जिसके basis पे हम लोग, जिसके लिए हम लोग इसको इस तरीके से shuffle कर रहे हैं. What is that thing? This thing is bit reversal. You see what is it? Very easy for you. You know it already. You see, memory address for decimal and binary. Look into these two columns. Don't go in any other column. Only these two columns. Look in these two columns. Okay. Only these two columns. Okay. See. You see, in decimal, for x for n equal to 8, we write x0, x1, x2, x3, x4, x5, x6, x7. There are total 8 points from 0 to 7. Okay. Now for decimal 0, in binary it is expressed as 0, 0, 0. Clear? We all know this. 0 is expressed as 0, 0, 0. 3-point binary. Okay. Now, you see, for 1, it is expressed as 0, 0, 1. Now, do you know how this 001 is representing your 1? Do you know? You see, this first 0, look at the cursor. This first 0 is multiplied by 2 to the power 2. Okay. The second 0 is multiplied by 2 to the power 1. And the third 1 is multiplied by 2 to the power 0. So what it is coming? 0 into 2 to the power 2 means 0, plus 0 into 2 to the power 1 means 0, plus 1 into 2 to the power 0. 1 into 2 to the power 0 means 1. So 0 plus 1 gives you 1. Similarly, for 2, it is expressed as 0, 1, 0. 0 into 2 to the power 2 plus 1 into 2 to the power 1 plus 0 into 2 to the power 0. So gives you 2. Similarly, for 3, it is 0, 1, 1. 4, it is 1, 0, 0. 5, it is 1, 0, 1. 6, it is 1, 1, 0. And 7, it is 1, 1, 1. Clear? Now, come to the total part. I have highlighted the total part right now. Come to the total part. You see, memory. X0, X1, X2, X3, X4, X5, X6, X7. Clear? Now, the data decimation 1 in the first stage of decimation. It is X0 comes as X0. And in the for the second stage also, obviously X0 is X0. For X1, you see this is X1. Okay. Now for data decimation 1, it is X2. After X1, it comes X2. Then after data decimation 2, second stage decimation, it comes X4. Okay. Now how is it? How is it? How is it? Come in the downward form. You see, read the theory. You see, by expressing the index n in the sequence in binary form, the order of the decimated data sequence is easily obtained, obviously, by reading the binary representation of the index n in reverse order. Bit reversal, the term is bit reversal, isn't it? So bit reversal means we are reversing the order of index n. Okay, we are reversing the order of index n. In other words, when n equal to 2, the input sequence must be stored in bit reversal order for the output to be computed in natural order. As an example, you see the data point x3. x3 means, you see, 0, 1, 1. 3 means 0, 1, 1. If you reverse it, it comes 1, 1, 0. So what is 1, 1, 0? 6. So you see the x3 term in the final stage, it comes 6. Okay. Actually, this is the normal order. This one. This first column is the normal order. And the last column is the third column is the bit reversed order. Okay. So this is the intermediate column. The middle one is the intermediate column. But x3 turns out to be x6. Why? 0, 1, 1 turns out to be 1, 1, 0. Okay. So you see. Placed in position m equal to 1, 1, 0 and equal to 6 in the decimated array. Okay. Thus, we say that xn after decimation is stored in bit reversed order. The figure below shows the shuffling of the data and bit reversal. You see. Decimal n2, n1, n0 comes as n0 into n1 comes as n0, n1, n2. Means actually n2, n1, n0 will be obviously n0, n1, n2 if it is reversed. Okay. So in case of 0, it is 0, 0, 0, and for reversed order also it is 0, 0, 0. But in case of 1, you see. See, in case of 1, it is 0, 0, 1. It comes as 1, 0, 0. This is the intermediate stage. You may not follow the intermediate stage also, no problem. If you don't want to follow this intermediate stage, no problem. Just reverse 0, 1, 1, 1, 0, 0. 0, 1, 0, obviously it will be 0, 1, 0. 0, 1, 1, 1, 1, 0. 0, 0, 1, 1, 0, 0. 1, 0, 0, 0, 0, 1. 1, 0, 1, obviously it will be 1, 0, 1. 1, 1, 0, it will be 0, 1, 1. And for 7, it is 1, 1, 1. And Obviously, the reverse order will also be 1, 1, 1. Okay, so now you understand. You see, x0, x1, x2, x3, x4, x5, x6, x7. How it comes? x0, x4, x2, x6, x1, x5, x3, x7. This is your input data. So our input data is bit reversed order, but our output is normal that we get. Clear? This is your bit reversal process. It's very easy, and this is all about your bit reversal process. Okay, thank you.